Welcome to This Explainer. If you've ever woken up in a cold sweat just thinking about letting an AI loose to optimize the absolute most critical loops in your codebase, well, you are definitely not alone. Today, we're diving into a really structured, highly disciplined way to handle performance tuning using OpenAI's Codex. It's an approach that keeps you firmly in the driver's seat.
Because it really is a high-stakes question, isn't it? Do you actually trust an AI to just rewrite your hot loops? Sure, asking a general-purpose LLM to boost performance sounds great, and it can be super helpful, but it almost always leads to these risky, totally unbounded code rewrites. I mean, if an agent decides to just speculatively rewrite a critical loop without any guardrails, it can completely and silently break your app's behavior. No thank you.
So to fix this, we're going to explore a specific Codex workflow that totally separates analysis from action. Our agenda today covers the AI refactoring problem, unpacking Codex skills, meeting the optimizer tool, looking at its report versus apply workflow, and finally, best practices and limitations. Let's jump in.
Okay, Section 1, the AI refactoring problem. Let's get right into why developers are naturally and rightfully pretty skeptical of automated refactoring.
Just look at the massive difference in how we actually talk to these AI models. If you use a naive prompt like, hey, optimize my code, you're giving the AI zero success criteria. It's totally unbounded, which brings a huge risk of silent regressions. But if you use a structured skill invocation, something like a $complexity-optimizer command, you're boxing the AI in. You're enforcing strict boundaries and a reliable, structured schema.
When you just blindly ask an AI to find performance issues, what you usually get back is a wall of unstructured prose. It doesn't give you exact file paths. It completely skips those crucial before and after complexity estimates. There are no explicit risk labels, and worst of all, it just goes ahead and modifies code without any test coverage. Speculatively rewriting a hotspot without running tests, that basically throws the whole discipline of safe software engineering right out the window.
Moving on to Section 2, Codex Skills Explained. Before we look at the exact tool, we've got to understand the underlying architecture straight from the official Codex developer docs.
So, what is a Codex skill? Basically, it's a reusable, tightly bounded capability that you invoke by name, usually with that $sign syntax, like $skill_name. Skills let you package up your instructions, your context, and your logic into one repeatable tool that Codex can call on. This gets us far, far away from typing out long, error-prone manual prompts. You define the behavior once, and boom, you've got a repeatable, auditable workflow.
Section 3. Meet the optimizer. This is where we look at a specific tool that perfectly leverages this exact skill-based architecture.
Let me introduce you to the codex-complexity-optimizer. This is a super clever NPM installable codex skill created by the GitHub user kappa-mn-git. What does it do? It hunts down algorithmic hotspots and performance bottlenecks across your codebase. But here is the absolute best part. It does all of this without touching a single file. You install it straight into your standard Codex environment, and it forces any file changes to wait behind an explicit human confirmation step.
It enforces a really strict separation of concerns. Step 1, Codex analyzes your code and spits out a report. Step 2, it pauses and waits for you to review those findings. Step 3, it only applies changes when you explicitly tell it to, and then it validates everything with tests. It's this exact separation that stops the AI from just going totally rogue in your repo.
Section 4. Report versus apply. Let's look at the two distinct operating modes that make this skill such a game changer.
By default, the optimizer runs in a report-only mode. It scans your codebase and gives you this really clean, read-only table. For example, in a Node.js project, it will pinpoint the exact file and line number. Say it finds an O of n squared nested loop. It'll recommend a map lookup to drop that to O of n, label the risk level as low, and even tell you exactly which test file you need to validate the fix. It maps out the whole plan while altering exactly 0 lines of code.
Once you've reviewed that report, you take the wheel. You fire off an explicit apply prompt, giving the AI strict boundaries to execute just one specific low-risk change from the report and demanding it run the test right away. And if the tests fail, no big deal. Nothing is permanently broken. You just have a simple diff to review and discard if needed.
Section 5. Codex Best Practices. Now this two-step process isn't just some clever open-source hack. It actually perfectly mirrors OpenAI's official documentation.
Look at the official best practices. Keep analysis separate from mutation? Yep, check. Turn repeatable work into skills? Check.
Improve reliability with testing and use sandboxing? Absolutely. By generating a read-only report before it does anything and validating with tests, this package is literally the perfect manifestation of OpenAI's blueprint for building trustworthy AI agents.
Section 6, Limitations and the Future. The methodology here is incredibly solid, but to be fair, we do need to talk about the current limitations of this specific package as we look ahead.
First up, as of this analysis, the codex-complexity-optimizer repo has exactly one commit. Just one. That means this is a very early-stage tool. It doesn't have a long track record in production, it lacks issue tracking, and it doesn't even explicitly document which programming languages it handles best. So definitely treat it as a brilliant but early proof of concept. Also, remember that actually detecting these performance issues relies entirely on the underlying LLM itself. And honestly, algorithmic complexity analysis, like really grasping amortized costs, or sniffing out hidden O-event operations buried deep inside library calls, is still pretty tough for AI models. So use the report as a great starting checklist, not a flawless, guaranteed audit.
Which brings us to our final thought today. Are you building actual tools for your AI, or are you just sort of throwing prompts at the wall and hoping for the best? Treating AI as a disciplined teammate, using structured skills and bounded tasks, is absolutely the key to safe, automated engineering. Don't just cross your fingers. Build a workflow. Thanks for joining me on this explainer, and I'll catch you in the next one.